tell me when to start talking and I'll start talking.
I can introduce this. Okay, hi everyone. All right, we are going to be talking about a new capability for making, well, trees that represent the structure of code in Wolfram language. So, Tom, why don't you take it away and show us the create data structure?
Yeah, fine. So the specific thing is a data structure wrapping of the code parser that Brenton's been working on and is used as the basis for lots of, tools and things.
Yes, it's an exciting thing. Right.
And we believe that a data structure wrapping would be a useful thing. So this is all proto code, not much. I mean, there's an implementation, but not of this. And I think it would be useful to nail down some specific names.
Right. So let's just understand. This is the thing that one would use both, the front end will parse notebooks into this. Is that a fair assessment? And when we're doing code assistance, we're parsing inputs into this. And when one's manipulating code in general, this is what one is likely, one can make it into an expastruct. One can manipulate code at the standard top level where things will evaluate whenever they can. One can turn the code into an expastruct, in which case it's a structurally identical to the final, to an expression, but it isn't, but the evaluator won't get its fingers on it. And this is a representation of the original source for the code, which right now is primarily strings, and it is information about how the thing was extracted from the string and then what the representation as an expression is. Is that correct?
Yes, I think those are correct, with the caveat that without some work that's not massive, but would need some work, the front end would interact with this through the evaluator, not directly. So, but it could be made to work with this directly, with some things.
Well, John, can you comment on that, please?
So, Stephen, I think what you're thinking of is that the intention to connect the same backend that's driving this to the front end, but the things that are communicated between the backend and the front end are a little different from what we'll see here.
Okay. Now, meanwhile, here, this would be the thing that, toString could have a version that goes to one of these. Is that correct? I'm sorry, to expression. The from string, something that goes from a string could go to one of these rather than going to a...
Yes, it could do. It certainly could do, yes.
Which is what you're showing in that first example there.
Yeah, there's different sources of inputs. So it could
that's very different from what we usually do. Usually in building a data structure, the step of actually building it from the source material that you give is trivial. Here, that step is not so trivial, and it could fail. It could have a syntax error, right?
Well, I could make a linked list and give a sort of massive, a list of a billion things.
No. I understand, but the transformation is straightforward.
Conceptually,
right?
Yes.
But here,
you're correct. Yes.
Right, and it could, in particular, have a syntax error.
Well, this swallows syntax errors, so it doesn't.
I see. So there's a representation of a thing with a syntax error in the code parse. Is that correct?
Yes. Okay. That's correct. Yes.
So right now this is working from strings only, not from boxes. Is that correct?
I think this can work with boxes as well. It can work with boxes. There's underlying implementation.
Oh, I see one there. The third element, the third example there. Cool.
Yes.
Okay.
So it would take boxes, and then it would be able to do things.
All right, let's start seeing it. I think I understand the framing. Let's see.
Right, fine. So there are these three different.
Let's just run the first one there.
No. I said I can't run things. You see, this is like read only. So.
Okay. Well, then, so show me what the heck is the potential output.
Well, the potential output would be like a data structure. There'd be a summary.
I know, but what is it like? What is the data structure? What's in the data structure?
What do you see when it comes back?
No, I understand what you see. You see a summary box. I'm asking, what is the structure of the data structure?
What does it contain?
Yes, that's what I'm asking.
Right, fine. So it contains the tree of the thing that you've been getting.
But it's an annotated tree, isn't it?
Yes, absolutely. Now, can I just show one more thing, and then I could show some concrete, some specific examples. So there are these 3 different forms, each of which is useful for different types of analysis of the file. So this is kind of this one here, and we could change these names if we didn't like them, but this is the raw material from the source. So this is kind of like the lowest level type of thing. Then there's another version of this which is similar to that, but it's stripped. It's stripped of white spaces and comments. And then there's a thing here that's like the actual expression.
I get it.
But it's in a structured form.
Right.
With all of these contain source, sort of attributions. So in a file, it's like line and.
Yeah, I get it. I don't think this line is right. Okay, so because I think what you're doing here, which I think is wrong, is to stuff in to create data structure what is essentially a sort of 2-parsed thing. Okay, there are multiple things. I'm not, this
fine.
is a fine operation, but what I think should be done is this needs to be, don't pretend that this is creating a data structure. I mean, it is creating a data structure, but it is really doing a piece of parsing here. And there are different levels of parse tree that you can get out. And I think that should be a separate function. But I want to see, for example, if you take the code parse tree and turn it into a tree object, where does that happen?
Well, so there would be a function. So first of all, it's going to have things that are sort of useful and special. Why don't I just whiz through things quite quickly, because some of these things are useful for code parsing, and some of them so here's the thing you might want to do is you've got the data structure and you want to check that it's valid syntax, and you might want to get a list of the subtrees that have errors. So obviously if it's valid syntax. So that's a bit different from a regular tree that doesn't have things like that.
No. Wait a second. A regular tree could have, you could just be doing analysis of a regular tree to get these pieces out. Or you could have a structure that has nothing to do with the regular tree structure, and every so often it drips out an actual tree. Which is it?
I think as I understand it, it's the second. So
but can we see something which is a representation of the actual structure that's underneath here?
Well, here's kind of like the sort of full form of this. So this would be something like the, this is the expression version. So this is what would be put into the, you would reach this. So you would do, in this, you would do create data structure, you do like a code parse data structure, you would give it this input.
Okay, my question is this thing that you have here is its own custom structure. So we've got right now, in the system, we've got several different things running around. Okay, we've got let's enumerate them. Okay, we've got the tree data structure. Is Ian here to represent that?
Yes.
Yeah.
Okay. All right. We've got trees. Okay. We've got the text element structure used by text structure, right?
Right.
We've got Chris Cooley's, the output of his code structure function, which I don't remember exactly what it looks like.
Yeah, code element and code element token.
Okay. And what other things do we have? What other
XML element, notebook?
Okay, fine. Okay.
Expression.
Well, and isn't there, what is this? So for context, isn't there already something in the code parser Packlet that's like a top level version of this? I mean, there's this serialization you have here.
That's this, yes.
Okay. So
It's
there's
just
that
that this is
ability too.
verbose and expensive and limiting, you see.
Well, okay, so actually that was going to be the other question I was going to ask earlier. Just a very naive question, which is one, what is the value of having this in a data structure? And two, what is the value in having this visibly as a data structure as opposed to just being a totally, generic thing where you just run code concrete parse, but then secretly on the inside, there's a data structure hiding there.
Well, what does code concrete parse return?
Well,
And you've got to imagine this is
Forget about the name, but
100, 2,000 line file.
no.
not this.
Look, here's the point. Take trees, Ian's trees.
Mhm.
Okay. Underneath, they're using data structure. But at the top level, what you see is this nice thing called tree that has lots of functions associated with it. It's
Even that's actually not correct. So tree manipulates tree expressions directly.
What a tree
right.
expression.
Like the
It's just the
full
focal
form
point.
that you see of tree, that's what we're manipulating. We make it atomic so that only the tree's code is able to break things apart like that, but we're just manipulating the actual expression.
Okay.
Right, and my understanding is that the compiled stuff that was there just worked by taking that expression, serializing it into a data structure, doing an operation, and then deserializing it back to an expression. Or
And it's not compiled now, or what's happened there?
So okay. I inherited the project. It was completely implemented in top level. Then we were using the tree data structure from the compiler, and the functions directly worked on the data structure.
Yep.
Right. Then in 12.3, we released tree. And the way that worked was whenever we needed to do operations, we did like Christopher said, and we serialized or deserialized it into a data structure, did the operations, and then reserialized the result back.
Okay.
Then in 13.1, we added a new algorithm for doing depth first traversals and also extended tree to have associations. And so at that time, we took out the serialization and deserialization into data structures.
So I don't understand. I thought tree was a success story for the use of the compiler. Is that not correct? Seems not.
I don't.
It's not really using the compiler in its current form. The goal was to eventually have everything be completely compiled, but that's not been tackled yet.
Right. And honestly, I think that it seems like, given the serialization problems, it seems like the way to do it would be to do something much more analogous to what people do in like kernel C code, which is that you just have you just have compiled operations, but they're operating on the actual tree expression as opposed to having to convert it to a data structure.
Yeah. Okay. All right. Well,
so that would be like an
misunderstood
extra struct then. That would be like some extra struct wrapping. So, but yeah.
Or it will be, I mean, in the this, none of this is released, but I mean, like a list expression based type thing. I think that would be the way to do it.
All right. So let's go back here. I mean, right now with text structure, for example, we've not been successful. I mean, there aren't functions that operate on text structure particularly, to my knowledge. With XML, so Ian, you are redoing the XML stuff.
Right. Well, this is why we're adding an expression tree converters for all of these things like text element and XML element. The idea is at the first approximation that you would convert these things into a tree, do tree operations, and then convert them back.
Okay, but this thing here is not interconvertible that way. This code parse is somehow not like that.
So in the prototype build, you can feed this container node object into expression tree.
And it turns it into your kind of tree.
Yes.
Can you show that, Tom?
No, I can't, but does someone else have? Ian, do you know how to do that?
Yeah, let me make sure it works on my machine real quick.
Okay, so what you've invented here is a whole other syntax for container nodes and et cetera, right?
Yes, that's kind of the idea. Yes.
Right. So that's what we have to focus on.
Yes.
This isn't just an appendix.
Right. We haven't implemented much of the appendix is just to show some sort of
I know, but this is the main event design-wise.
Right.
But for context though, is there an existing, although maybe it only exists in some packlet that hasn't really been seriously cleaned up, but like, you know, is there an existing interface for manipulating container nodes, the top level ones? It's maybe a question for Brenton. Yeah.
Well, yeah. So, I mean, I wasn't thinking that this was really the main event. So with this data structure stuff, if you're working with expressions at this point, then yeah, there is no point to having the data structure because, you know, you're working with these expressions. We haven't really touched on the advantages of just having a data structure that you work with yet. And this, what's on screen, this has existed for years now. This
But it hasn't been exposed to users.
Correct, but
Correct.
I mean, we were planning on talking about the data structure more, where you don't even see these things because of the efficiencies that are afforded by using the data structure, which I mean, we haven't gone into yet, but there are operations that are not possible with expressions that if you turn everything into an expression, sometimes that limits the expressibility of what you can do sometimes. And so just the example that I just go to is you have a tree, but then you want to, you know, talk about its parent. It's like, well, you know, you can't, you know, expressions don't have a parent. You have to talk about the entire expression.
The flow of what we're doing here is you have a certain underlying infrastructure that you've built for dealing with code parsing. Okay. What we are trying to do is make a user exposed version of that. And, you know, one approach would be go and try and document all of the details of what's here. What we're, I think, saying is, let's make a data structure based thing that we can document and that is useful to people. It will underneath be using things like this, but those are not things we will document at this time. Is that the correct flow or not?
Well, I think you might extract parts of these. You might want to extract parts of these when you've navigated down. You might want to get.
Then they have to be fully documented.
Yeah, fine. No, I absolutely. In a sense, this is the data that's stored at various parts of the tree.
Okay, but then I don't understand. Why aren't we just?
Can I share my screen? I'm ready.
Yeah,
Go ahead.
sure.
I mean, I only brought up the question about the top level thing because I'm just.
Go ahead, Ian.
If there's already a design that's sort of like, you know, or if there's sort of a tentative design for this whole interface that doesn't use data structures, but it's just the one that Brenton has been using, it might be worth looking at that if we're, you know, so we don't just
I agree.
make a whole new design.
Yeah, we don't need to make, I mean, look, if we're going to, okay, here's the thing. If we can do this purely at the data structure level and freshen the design there, so be it. What are you doing? Could you make it? Yeah, okay, thank you. You know, what we don't want is to say, well, we got this data structure layer, but then when you do anything real, you drop down to an undocumented previous layer. That won't work.
No, I would prefer it if you never, if people do not drop down as much as they can. Yeah.
Well, no. But if you ever drop down to this level.
No, I think you need to know something about what's there at the data level.
Yeah.
So,
If you ever drop down to that level, then that level has to be designed.
Yeah, obviously, yes.
Right.
Yes.
But then, okay, fine. All right, go ahead.
But in this meeting, since the title of the meeting was data structure, this is the you know, we have to decide whether it's necessary to have it. Right.
Okay. Let's see what Ian has here.
Right.
Ian. Right. So this is code concrete parse returning a container node with all of the special node types.
Yep.
So this is the tree that you can get from the expression tree.
Yes.
And this is the data stored at each node.
Okay. So I don't understand. Tree expression there. I'm confused. Can you scroll up, please? Expression tree of that thing, comma code. So code is your code word for take a Brenton code thing and turn it into I'm confused here. Tell me
Yeah,
what's
that's
going
correct.
on. Okay, so
Code
it's
is the
taking,
structure for what's returned by code parse.
which is the container node object, correct?
Yes.
Okay. And you're turning that into what there?
This is a tree.
Which, if I were to go tree expression of that, what would I get?
So with the second argument, you get the original
No,
expression.
I don't want the second argument. I want the default of tree expression there.
Okay.
So in other words, do I then get, I'm confused. Do I in fact get the pars? I'm totally confused here. I get, what the heck?
I mean, so by
Oh.
default, tree expression uses the data as the head and the children as the arguments.
Okay, I'm sorry, I'm confused here. Let's go back again to what's going on here. What we've got from Brenton is representations of the pars with different levels of tagging, correct? 3 levels of tagging. Am I correct?
Yes.
Okay. Now, first question is the object that is produced there structurally a tree? Forget about whether it's a tree in the Ian sense. Is it structurally a tree? Or does it have additional tagging that makes it not structurally a tree in our sense of tree?
It's a tree. That's true, isn't it, Brenton? It is a tree.
Yeah. Yes.
But does it
Yes.
have additional tagging? So a tree for us has a payload at every node and subtrees at every node. So everything you're doing, so if I look at this container node object and so on, this is, how would you represent that? And maybe this is what you're doing here, as a tree with payloads and subtrees at every node. Do you understand my question?
That's what this is doing. Like here is showing it without the labels. Like all of the extra tagging, I'm just dumping all of that into a list and using that as the data.
But that's not very nice. I mean, Brenton has a perfectly nice structure there that has, I'm confused. Okay, there is a tree structure that corresponds to the structure of the expression itself, of the parsed expression.
Yeah.
And there is I'm okay.
Right. Well, that's like it's the same issue with text element and XML element. Like the underlying expression is itself a tree, but if you work with
that's
that
why
tree
I'm
structure,
saying. That's why I'm saying.
the
I
actual
don't think it
structure.
is. Right. I think that these things, which are essentially decorated, annotated trees, are not quite trees in your sense. Do you see what I'm saying? There's some additional structure there, which is standardized structure, which is things like where the source thing is and so on.
Mhm.
Isn't that just data that's stored at the nodes?
Yes, but okay, but maybe there needs to be a standardized format for that data, because just putting it all on a frigging list is not doing anybody any good. Right? That list is silly. Am I making sense? What you're doing is you're taking a structured object that Brenton has, and you're just randomly crushing it into a list.
And it could be an association.
Well, into the data part and the children part. We've got one slot to put data in.
I know that. That's why I'm saying to you, I don't think these things that Brenton is making or that XML is making are quite the same trees as what you have supported.
Well, no, I think the point is that they're not actually topologically different. It's just a question of whether you have extra structure in the data field. In this case, the data is just a list. If the data were an association and you had a nice label, I don't know what the function is called, vertex label function or something like that, then we would not be complaining. We would not be having this discussion.
I know.
And that's what's happening up here. Is there's a label function.
Yeah. Okay. But fine.
Right. So but the point is, these are still trees. It's just that they're made prettier.
I understand that. So what I think it maybe needed is a standardized format for the nodes that isn't just, and please, the thing that you're doing there of just putting the random things that Brenton has in a list, this is just going to end very badly. Because in different,
but to be clear, you're contrasting that with just putting the random things in an association.
for example, yes, or some standardized structure that we define that is yet a different thing, more like text element, that is a known structured object that represents an annotated tree element. Do you see what I'm saying?
I'm just saying this is not a fundamental complaint. This is just kind of a complaint about, like this is not a problem with using trees. It's just means like,
it's not a problem with using
you can
trees.
be more careful about
It's a problem that I claim that there is something, maybe it should be called, annotated vertex or something. I don't know what it should be called, right? Something which is a standardized version of how to do something which has both a structural meaning and annotation. Does that make sense? Ian, you understand what I'm saying?
But isn't that like data and metadata? Just different names.
Sure. Yes.
I think this is a bit like encoding. This code second argument is acting as an encoding. And so it's important that we remember which encoding we used so that we can undo it.
Yes, but I mean, so returning something where the elements are just lists of random things like container node is a very bad idea, right? Because then we didn't store anything. We just splattered it all over the place with random little pieces of its innards. Am I making sense?
Right.
Ian, do you understand what I'm saying? So I'm saying we don't want to do this.
It's like, so right now, text element and XML element represent trees. And this is like changing it so that you use tree to represent tree, but now you want some symbolic representation of the payload.
That is correct. Yes, you cannot just splatter the payload into pieces of a list. Okay, so I don't know what we're planning to do with XML element, but I think, perhaps,
it's the same thing. So,
well, don't do it that way.
The attributes.
Don't do it this way. Don't do it that way. Okay, bad idea. So, but instead, let's invent something which represents in a structured way an annotated node. Am I making sense?
Yeah, like vertex annotations in a graph, but for trees.
Perhaps, yes. Perhaps using annotation. I'm not sure, but
or really what it's like is it's just that the vertices instead of being what you display, the vertex is some big object.
Yes. Okay, so someone is asking on live stream, how is this different from graphic visualization in full form? The main point is that this has tagging information about how the parse actually operated, and it can deal with parsers which are not even correct parsers. Like if you remove the C there, right? That's an actual, there's no full form representation of that because it isn't a parsable thing. There's a representation of the syntax tree. What happened there with the star? Sorry, I didn't see that. Could you do that again, please?
Non-commutative. I mean, it's
show it to me again. Okay, fine. Okay, and put a third star there. Okay, fine. So this is what the weird. That's a weird parse. Huh. Weird parse. I'm surprised about that parse. What happens?
It's all about precedences.
Do we think? Okay, I mean, that's a partial parse anyway. But what happens if you just give a parse that is obviously? Just do this. Can you do it again at the top there? Something that's just obviously wrong, like plus, plus slash.
Just a mess of brackets and pluses and parentheses.
What the heck is group square?
The name for match fix operators. We can have not prepared for design review right now of everything, but it's, group list, group square, group paren, group ceiling, ceiling and floor and everything that can be match fix.
So these are the non-terminal symbols in the grammar. Is that correct?
Yeah. I mean,
so you've got names. Okay.
We don't have a grammar, but to be clear, but yes, they would be if we had one. Yes.
Okay, so wait a minute. So we've got a whole class of things here, which are the named elements of which your things like infix node is one exposure of one piece of that big structure that is the different sort of structural elements of a parse in the language. Is that correct? So how many, so do we have like 50 of these kinds of things that represent
Yeah, I mean it's prefix, postfix, binary, infix, ternary, that's different. Group nodes. The interesting thing is with integrals, because it's actually, we have integral syntax in the language, and it's actually a binary operator, but the operator is prefixing the two operands. And so I have, you make up a name, prefix binary operator, hard to come by in the literature for good names for things. But so I don't know, 10-ish, whatever.
Okay, fine. So
might be
so this is
two
another
more.
thing that has to be designed, right? Is this okay? So you've got this essentially
and obviously I forgot function calls and things there too. Yeah.
Right. So let me understand this. So these are kind of standardized names for tree nodes that have certain syntactic, that correspond to certain syntactic kinds of constructs, right? Is that right?
Yeah, I mean that's all these are. Mm-hmm.
Okay. So, and then for each of those syntactic constructs, you also have at your different levels in your concretified and so on thing, at each level, you also have various kinds of tagging, like what were the characters in the source that corresponded to this and so on, that mapped onto this. Is that correct?
Yeah, that's what source is. We see it here with the convention for line and column, but there could be other conventions. That's what all that source is. And there could be in theory more metadata, but I've just, there's not anything more interesting to add on so far. But crucially, when you're when you're talking about abstract syntax, there's no source. There is not source information associated when you do. Yeah, if you go back and take out the concrete again, just to show, various things do not have source. Like the symbol, the power symbol doesn't have a source in that input because it didn't appear there. So sometimes they're there and sometimes they're not.
Yeah, I understand.
If they're synthesized. So there could be a thing, I could say source rule synthesized or something like that too, if I wanted to be complete about it. But yeah.
Okay. All right. I understand. So, okay. So let's go back again. The purpose of all of this is to have a standardized representation of the parse tree that is manipulable and where, for example, let's say we have a parse tree, and we know that there was a runtime error somewhere. And then we want to indicate that in the parse tree. How would we do that? How would we?
Yeah, so I mean, there are errors here. So instead
make it simpler, just do A+ in that. It's a bit complicated. That, yeah, there we go.
And so in there you can see error node. So analogous to Leaf, all of these names are up for debate, but again, not prepared in this meeting for talking about this. We were prepared for data structure stuff, but this is the existing tech. Error node representing, obviously expected operand for that, but you could have other errors.
Okay, but this is a syntax level error. So my question is this, one of the things we want to use this for, or maybe I'm confused. I mean, in the case where it's syntactically correct, but at runtime, a runtime error is generated, and we want to store information even on something like the stack about what part of the initial source was being run when the error occurred, which
I see. Yeah.
which includes
Yeah,
here.
fine. So that's a very reasonable thing to want to do. So what we would do then is make it A plus B, for example, and it's right. Actually, sorry, make a function definition like f bracket colon equals f open bracket colon equals x. Right, brilliant. Right, let's do that. So we would want to maybe somewhere with the down value store the name of the file or the box ID and the position in that file or the input string. I mean, the string's not so interesting, but we could then go and store that somehow in a way that has to be determined where that source came from.
Right.
And another virtue, can I say one other thing? Another virtue of the data structure interface is it's quite efficient. And so we could, and the data structures are also quite integrated into the kernel. So we could actually switch getter needs to call the data structure parser rather than the existing kernel parser. And then we would get this information flowing into it. Just
okay, so let me understand what you're suggesting. So you're saying in down values, somehow, that we would store the data structurized version of this source information.
Yes, I think so. Yes, I think, yes, that's correct. We would store the source information that had been generated by the parse. So,
right,
and there's a bunch of ways we could do that. So,
okay, but there's one thing in the down values is just the straight code. This is the code to run.
Yes, but we can have
also
other stuff as well, right?
Okay, but then there's also, this is the annotation of source information from the raw code that is, so we might have two pieces. We might have in down values, we might have, I mean, right now what we have is the left-hand side and the right-hand side. And you're saying there's an additional piece, which is the kind of source provenance of that down value element.
Right. So that's a very coarse-grained notion of source information, but it would be useful for messages and things like that. I mean, you could know what notebook it came from. You could know what.
Obviously, right. I mean, but that's
things like
okay.
that.
But I mean, okay, all right. So fine. So we're talking about storing a thing.
If we had more fine-grained information, we could know what subpart of the expression could be stored. So we were talking about the compiler errors. We could go and mark up the coloring in the source notebook. You see, if
yes,
there's quite a bit of plumbing and machinery to reach that.
Tom, do we want to go back to your agenda here?
Sure, of course. I mean, I want to make sure we cover all of right. Fine.
Tom, can you share again, please?
Oh yeah, hang on. Didn't I share? Oh yeah, hang on. Right, here we go. Right, I'm sharing.
Okay.
So this is the data structure version, and these were some of the things that we, the different parsing structure. Then you can parse. You can get syntax errors.
No,
then,
I'm not getting this. I'm not understanding this so far. So I mean, we've got this whole giant sublanguage of essentially our syntax tree sublanguage.
Right.
Okay.
So supposing I did, let me just give a demo, an example.
No, I want to ask a question. I mean,
sure, go ahead.
For example, in Chris Cooley's code structure, you must have similar kinds of constructs. Is that true? Or how did you do that?
Yeah, it's very similar to text element. And we, if you want the tokens, there's a layer of code element tokens. And every time you parse C, it's always going to give you a source range. So it's like for the element of a code element.
So maybe
yeah.
Do you want to bring this up, or can Tom bring it up? There's a WFR entry for code structure, right?
Yeah. Why doesn't Chris do it? Because he's probably better at demoing it.
Yeah. Are you ready to do that?
Yeah, so it's very simple. It just looks like this, right? And you'll notice the source range.
Okay, but so you have things like function decal and
Yeah.
etc. Okay, so that's your analog of what Brenton is naming. You know, Brenton has names for certain elements of our language,
Mhm.
like a group, you know, a ternary group thingy dingy or whatever it is, right? And you, so everybody is having sort of named, has named pieces of the syntax, so to speak.
Yeah.
Okay. Now, how analogous is this to what Brenton is doing? Brenton, can you comment on this? You know,
I'm looking, this is the first I've seen. I'm just looking. I mean, it seems very analogous.
I
at
know
first-
that's why
at
I'm
first glance.
yes, that's why I'm bringing it up, right? So, but what seems to be the case is that everybody has certain, you know, what should I call them? Certain tags, names, whatever, for syntactic pieces. And there's a question of what should those be? Should those be entities in the end? Should they be what should those be?
Well, so I can speak a little bit to the design, which I mean, I wasn't prepared, but everything with the design that we were seeing before, that Ian had on his screen before, with all of my symbols and my names and things, efficiency was the key.
Fine. So what are those things? So they're just
being able to dispatch quickly on the heads and the first arguments because of the choices that you probably want to make, you know, based on, you know, what
okay, but how are they implemented? What are they? Your container node, that's just a symbol, right? Container node is a symbol, true or not true?
Yeah, these are all just, there's no implementation. I mean, we're talking about the representation, like what's on screen now, like there's no implementation underneath this. This is just, this is all symbolic.
No. I'm asking the question. If you introduce your ternary group operator or whatever it is, you know, your thing that's analogous to Chris's function decal here, right? My question is for Chris here, function decal is what? Is that a string? Is that can you do like input form of that thing or something?
Yeah, I think it's a string.
Okay, so you have certain named strings and you have certain structural pieces like your code element token, which is probably something analogous to something Brenton has. What is Brenton's analog of code element token?
Well, if it's a leaf node is what I'm calling, you know, the end points.
Okay, so fine. So that might be that your leaf node, which is again a function for you, or a symbol for you, right? Just like it's a symbol here, code analysis backtick code element token.
Yeah.
Symbol here. Okay. And then it has certain things in it, like the punctuation piece there is saying what kind of a thing that is, right? So what Chris seems to have here is the raw string, the what kind of a thing it is, and then certain tagging information like source range. Is that correct?
I think that's a reasonable way to describe it.
Okay. So you're always got, I mean, is it always a three-legged animal, so to speak? You know, that everything here is a code element token with the source text, the description of the nature of the thing, and annotation information. Is that right?
Well, for the code elements, they've got, you know, they've got the child elements, the thing it is, in the source range.
Okay. Thing it is. Wait a second. So, okay, so if you were to represent this here in terms of trees, your code element token is a leaf. Is that correct?
Yeah, and so I can just show what it looks like. You know, this hasn't been integrated into the trees project yet, but like if you want to, let me try to find something that's a little. Yeah, you can see it's kind of have a different, it has a little bit of a different formatting. You know, we just give you the actual text. We don't give you we don't give you information about what kind of token it is.
Here, although in the case of text element, the text structure, the analogous thing, text structure is putting a line under there and saying noun phrase or something. Isn't it? I would recommend whatever your method of finding this is.
Chris has a form of displaying that,
Yeah.
like the
So, I mean,
underline.
this is yeah. So they kind of give you the type of the,
Right,
the word
there,
here.
I see.
Yeah.
Yeah, right. So
But
that,
if you displayed it in a different way, like Ian's talking about, you can get that information, and that's called this annotation thing.
okay. All right. Let's go. So Brenton, so this is literally the first you've seen of Chris's. I mean, this is from years ago.
We have looked at it actually. I think so. But yeah,
Okay. All right. So Tom, let's go back to your screen if we can.
sure. Right. Fine. So, like for example, I don't know if you can see this. So if you did,
Can't see anything right now. You're not sharing.
oh God. Right, that will help. Right, fine. Now you can see. So in this idea, if you did something like this, so syntax Q would return true, and then
Would
when you
return
got
false.
parse, this would
Would
return
let's
also
let's say false for
It would
that.
return false in that case.
syntax Q. Yeah, well, let's say that. Right, and then you ask the errors, you'll get a list, and these would be also data structures that are sort of pointing inside of the thing that represent the error nodes as data structures, you see. So, okay.
Mm,
I mean, maybe we don't like this. This is just an idea. Okay.
Look, again, let's go through it again. Okay. We've got.
Why don't I just whiz through a little bit more of this, and then let's go back and go.
If you want. All right, if you want.
Oh, sorry. I mean,
No, go ahead. Go ahead. If you've
Right,
got
fine.
something,
Okay.
sure.
Super quick. Right. So extract subtrees based upon position and things, and then that we need some sort of path mechanism to reach siblings and parents. And I think there's a tree designed for that. Now here's some more, like some sort of cases
This is
notion.
horrifying. But yes, I understand the functionality is good. The design.
Right, fine. We can unhorrify it maybe. So this is similar to tree map, level
It's just
specs.
crazy. I mean, it's just crazy. We're making up some bizarre backwards syntax because we're trying to avoid having this actually using cases and so on.
Well, fine.
Absolutely correct. Yes.
If we can figure that out,
It's
that would be
crazy,
great.
right? We
Right.
can't.
No,
do it.
it's not. Think about it. We have 5 gigabyte data files that need to be parsed,
Yeah.
and it would be the definition of insanity to bring in the expression version of those. Just
No, you're not understanding what I'm saying. You're not
But-
understanding what I'm saying.
But
You're not understanding what I'm
so
saying.
hang on, Stephen. What are you saying then? Right.
Right. What I'm saying is this syntactic form is wrong.
Fine. So
Okay.
let's have a different one.
But what I'm saying is I'm not saying that the thing on which we operate is a traditional communal garden expression, right? That would also be wrong. We need to have some mechanism to use. We cannot have a backwards, pseudo syntax for 30 different functions here. Okay. So what instead we need to
I mean,
do,
in a sense, with the tree project, that's exactly what was done, because there's tree map and tree extract and tree.
I know,
right.
I know, but it's not.
But if you don't
backwards.
like that,
it's not done. No.
Yeah.
It's very good because it's been specialized for trees in a way that's. But here you're doing this backwards. El Cheapo. We're just going to use strings in sub-value positions.
okay, fine. So you could have you want something like this: parse cases.
If we want to do that, yes. If we
Right,
need
fine,
to do
that would be
we
fine.
need to do that. It's not obvious to me that we need to do that.
So
but
you want
yes.
this to work?
Possibly, I don't know.
Yeah,
Or I
fine,
want
fine, right.
something that's
I'm
based
just-
on tree to do this. Okay, that's why I'm pushing on the question of, is this thing really like a tree?
Well, so the problem is tree is still just top level expressions.
You are worrying about implementation. That's
Yeah,
what
yeah.
you're talking about, right? I'm talking
Yeah.
about the design. Okay. I'm talking about what is the design. The implementation will be the same as what you have right now.
Right.
Well,
So
yeah,
what
yeah,
I'm talking
yeah.
about is the
What Tom
design.
has on screen. Yeah.
Yeah, we could have a thing like, we could have a function like tree cases that could work on this. That
Okay, but the
is that
point
what you're
is,
saying?
design wise, okay, they're two different things. There is the largely atomic sort of data structure based efficient blob of stuff that represents the 5 gigabytes of
Right.
data.
Mhm.
Okay. Then there is the way of representing functions being applied to that.
Sure.
Okay. Where the typical thing that will happen, just as it happens in trees or data sets or data structures for that, well, not data structures, trees or data sets, for example, is you operate with a sort of a standard top level thing, and the return is one of these blobs. Am I making sense?
Right.
Okay. And that's what it would be here. You got a 5 gigabyte blob, you use some nice, tree cases or whatever, it returns a 2 gigabyte blob, let's say, right? It's, blob to blob stuff. And there's some way of resolving at the end those blobs into, ordinary expressions. Am I making sense?
Exactly.
Yes,
If you
yes,
even
yes,
want,
yes.
if you even need to
You
at
are.
the end. Yeah.
Yeah, you
Yeah.
may not need to. You may just be using comparisons or
Yeah.
Yeah.
putting it out
Yeah.
somewhere else. Okay. So what we're talking about here, the goal of this is to design something that is, a usable, understandable thing. And we're not designing something that is going to have, all kinds of weird sub-value jokes by
Okay,
number.
fine. Right, fine. So,
I mean,
so
if that's how it
can,
gets implemented internally, so be it. But that's not what the top level design is.
right.
Okay.
Okay.
Now, what do you want to show? What else do you want to show?
Right, fine. I mean, these are just some of the things, we want sort of some way of navigating and updating. So that's kind of,
Arg, look at
yeah,
this
fine,
design.
whatever. Okay,
Why
fine.
would you
fine.
do it this way? But open that up again, okay? And let's do a little exercise. What should this be?
Well, you could have, like I put up there, you could have tree map.
Okay, so that's really the question. Could we put, could we overload Ian's tree star functions to operate on these, on these kinds of parse trees? Or do we need a whole new family of parse map and so on functions?
Well, there'll be functions that don't exist in the tree world. There is a tree cases. There may be functions that don't exist.
Well, but maybe they could exist or should exist.
But they could exist. Yeah.
Right. So that's the question. I mean, are they functions that are essentially structural functions that could be applied to trees? You just don't typically care for trees that aren't parse trees? Or are they things that depend on the fact that it is a parse tree?
Nothing that I believe nothing we're talking about depends on it being a parse tree. Like we're,
Except here's
traversal, the
one that,
mapping.
right. There might be one that is a bit like
Well,
that.
okay, fine. One at the end, yes.
Yeah,
Here,
but,
the
but
evaluation.
what you're saying is correct. I suspect, this would be, like how do you get the data from a tree?
Tree data.
Tree data.
Ian should say, but my vote would be for overloading the tree functions. Yeah.
That
Ian,
would be,
can you comment on this, please?
Yeah, I think that's kind of the goal is
Okay.
for
but then-
remap to be able to work on,
Okay.
also
let me
XML and
say,
element.
the one thing that's needed here is a standardized data payload for a parse tree, right? The thing that you had before where you splattered it into that list wasn't going to work. Am I making sense?
Yeah.
Okay, so what's needed is the thing that happens here will look like a tree, walk and talk like a tree. Its one special feature is that its data payloads will have a different form as maybe a parse element or something. And, that is directly analogous to Chris's code out. What was it? What are you calling it? Token.
Code element,
No, but then the inner thing, the token piece, the
code
leaf.
element token.
Okay, fine. So I believe that what's there is directly analogous to that. What needs to be there is directly analogous. I don't know whether you need two of those things. You might need two such things to be the payload elements in the tree. Am I making sense? Is this making sense, Ian, Brenton?
This has to make sense to Ian, to tree people. Sorry.
Yeah, you want some kind
Can
of
you
cleaner
explain
separation
this?
between data
Yeah.
and metadata.
Yes.
Yeah, I want standardized, and I suggest that Chris may have already developed this, and seems to have developed something incredibly analogous to what Brenton has developed.
Well, yeah, I mean, like, so the payloads and trees could be the actual leaf nodes, for example, that were already being shown too.
Which in your situation are what? What are your leaf nodes like?
Well, yeah, I mean, the order of the first two arguments are just reversed from Chris's stuff. What it is, and then the string version, the payload. So, and then source information. So, it looked like extremely analogous. Yeah.
Okay, fine. Okay, so then that's what we need. We need a named thing that is and that particular type of named thing, I could imagine being used for text elements as well.
Sorry, I have a comment. So one of the ideas in this second argument of tree expression and expression tree was that the same tree could be reconstructed in different ways. My interpretation of your idea is that when we go from the expression to the tree, we insert in the data the encoding that was used, the type of expression where it came from, which will help in reconstructing, of course, but will prevent reinterpretation.
Sorry. I lost something. Could you say that again?
Yeah, so this is one of these balances questions of encapsulation versus having information outside, I would say. So our idea was that the same tree could be reconstructed in different ways. Like, do you have an association? Do you want to see the rules or not? Do you parse it as an expression or as an association?
Yes.
And so if we insert the original type of expression in the data of the trees, then we are forcing that the tree will be reconstructed in that form.
I am slightly confused. I mean, you're saying that Brenton has defined 3 levels of abstractness or not for the parsing that's going on. I'm kind of guessing that Chris might have had a similar thing in CodeStructure, but maybe not, of different levels of parsing. I don't know. Maybe not, because okay.
I mean, I'm sure it's available from Clang. I mean, it uses Clang, I think, so I'm sure it's all available somewhere. There might be more things to do with macros. There's probably a pre-thing before the macro system runs. It might be more than 3.
With declarations and definitions and things, I mean, I would guess that there are 5 levels off the top of my head. Yes.
Yeah.
We don't have, Wolfram language doesn't have declarations, versus anything else. So yeah, 3 here, maybe more in other languages.
Well, but when we have the new package structure, I don't know if anybody's talked to Connor about that. There may be more layers when there's the new package structure.
Yeah. That's totally correct. Yes, there'd be a package layer as well.
Yeah.
Okay.
Which right now there is not, because with the package format version 1, that has always been existed and documented, begin package, those are just functions that execute. So, there's nothing special about how they parse, but, in Connor's, new, working on package format v3, there would be constructs that parse that are not evaluating, that need representation. Yeah.
Right. Okay. So, I mean, we need to wrap this up for today.
Right. There's one last thing that is slightly useful, and that's to use this tree to actually get the expression, the same as to expression and get do, like get the thing and evaluate the input.
Yep. I understand. Okay, so look, the thing we need to do, and well,
Yeah, that probably doesn't exist.
That probably doesn't
obviously
exist.
doesn't
Yeah.
exist.
That is quite special.
That's
for-
similar to
Things would be like
treefold.
tree expression. Yeah, tree expression and treefold would be the closest.
No. Tree expression, isn't that getting the data that's in there?
This is like treefold, with the evaluator being run at every folding step, I believe.
A top level version implementation of the evaluator, yeah, being applied. Yeah.
Right? That's what that is. Okay. So
maybe.
Okay. So let's come back here.
The only thing I'm unclear about, and maybe the tree people can enlighten me, is exactly how do you get data? How do you get metadata? How do you get both? How do you get what? What's the
I mean, that's all been defined for trees. That's all very nicely defined in trees.
Right. Can someone show me?
Well, could you go back to sharing, please? Because we've got to wrap this.
Sure. Fine. Right.
Let's not do that here. Could you
Okay.
go back to sharing, please?
Yeah. But
Okay.
we could work up much of this in terms of the tree
Right.
structure.
Let's just outline again what we're going to be looking for here. Okay. We're going to be looking for a payload, something that is a standardized thing in the payload that is called something like I don't know, structural element or something, let's just say, or sourced element. Let's call it sourced element. It's not a very good name, but let's say it's called sourced element. Okay. And that would be something in common between text element, code, the code element, and Brenton's thing here. And what it would contain is, as we all know, it contains the raw source. That's why we're calling sourced element. The raw source, the interpretation of this thing, as in it's a grouped ternary animal or whatever it is. You don't need to say grouped ternary thing, animal, as you wish.
Yep. It's a good.
And then the provenance information, right? Yes, e.g. source, blah blah blah. Okay.
But isn't this just metadata?
Well,
I mean,
no, I want to be specific here, because what's important about this, it is useful to say it is a pointer back to the source, right? Not just, we're going to give some random thing and it might be pointed to the source and it might be the phase.
You're saying this is required.
I'm saying for a sourced element, that's what it's all about. It's saying
yeah, fine. Okay.
From, right? That's because it contains the actual source. Look, there's two things about the source. What it was, brace, star, whatever it is, and there's where was that?
Yeah, fine. Okay.
And I think largely, if that's all that Chris provides and that's all that I provide in my association, then it's kind of strong evidence that that's all that we actually care about. Yeah.
No, I agree. But I think that given that those things are what you're providing, I think having standardized sort of positions for those and not even using, not even potentially having a tag name like source position or whatever it is, just those are the three things. Boom, boom,
Yeah,
boom.
it's good to disambiguate between the
Yeah.
different versions of source, because it could be line.
That's fine. That's fine.
Yeah.
That's fine.
Right.
Fine. There's some, but then there's a yet different thing. Then we need some kind of symbolic source identifier, right? That could be a file, a line number, whatever. Okay. Let's do that, because what we then want to be able to do is you extract the symbolic source identifier and then you say, show it to me, or color it, or do whatever else you want to do to it, right? So you don't have additional logic. That's all just something where you extract the symbolic thing and then you can do stuff to it. Does that make sense?
I think so, yeah.
Okay, so now what we're saying is there is a function that turns, it's a parse tree function effectively, or I don't know what it's like code structure. And it might even be that code structure, that we now finally introduce code structure into the language with code structure's default being Wolfram language. Do you see what I'm saying? Because it looks to me like this is really going to be the same kind of structure as code structure. And why not allow the possibility that code structure can operate on C and this and that and the other as well, if they are similar enough? Okay.
So the function is code structure.
Maybe, I don't know. Or maybe it's parse, or maybe it's, it's code. I don't know yet. Okay.
Fine. Okay.
And I don't know whether
fine.
it's a shared function between Wolfram language and other languages or not. Okay.
Fine. Right. Sure.
Okay.
There's quite a bit here to work with, I think.
Wait a minute. We're not done yet.
Okay.
So now, so the thing that gets returned by code structure, code parse, whatever, presumably is a tree whose only special might be, I don't know if this is correct, a tree whose only special feature is that its payloads are these sourced element payloads. I don't think that's right. I think it's going to need some outer wrapper around the tree where it says this is a code parse tree or something. Am I making sense? Where the innards is a tree that you could take out and just manipulate as a tree, just like if you wanted to, you could take a tree and turn it into a graph and manipulate it as a graph, but you would lose certain things which are part of the, tagging and other information about the tree. Does that make sense?
That's fine. So there's no data structure. There's none of that.
Well, I don't know. I mean, I think this could work using a data structure.
Well, where does the data structure go in this?
I don't know. Maybe it isn't needed because tree doesn't use data structure. I thought it was. Okay. Okay. So now the operations on this, now you want to do things, and this is where, because you need things like tree cases and so on. Do you have tree cases, Ian?
Yeah.
Okay, fine. So that's an argument for not using code parse tree, but just having a native tree. Well, I don't know. I don't know. I mean, it could be that tree cases is some kind of thing that if you give tree cases, if you ask for tree cases of a code parse tree, it does tree cases of the inner tree and then just wraps the resulting code parse tree. I don't know. Did you get what I'm saying?
Yeah.
No,
I'm not sure which
I don't. But
Well, let me explain it. Okay. The issue is you want to use the function tree cases to do cases type transformations on code parse trees.
yeah,
Okay. So the only question is, if we had an outer wrapper code parse tree, that would gum up the works of the naive tree cases. But we could have it be the case that tree cases simply, burrows through code parse tree, does the operation on the inner tree, and then replaces it code parse tree on the outside when it comes out.
it could do that.
Yes, I don't know if that's necessary. And it depends on whether there's metadata that needs to be kept in the code parse tree or whether we can treat.
So this is purely an application of trees. There's no data structure. It's just going to ride on top of the tree project.
I think so.
Fine. Okay.
Looking like it. I mean, I don't see any reason not to do that. Is there a problem with that, Ian?
But it's probably unusable for things like marking up down values and things like that, replacing get and needs.
I'm sorry. I don't understand that. No, I don't understand that. Look, I don't understand. We just went through this.
Okay, fine.
Okay,
Right.
look, we just went through this. Okay, if you need a special thing that is your special kind of tree that is atomic as far as you're concerned, right? Then have that. But the function tree cases then needs to work on that.
Yes, yes. That's what I'm saying. That would be totally fine. So then it's a code parse tree with some sort of atomic thing.
No, I'm saying.
Or it's tree with atomic thing.
It doesn't matter. It doesn't matter. It doesn't matter. No, code parse tree. That's fine.
Right.
But then write code parse tree there. But then the key point is that the functions that work on trees work on this the same way.
Yeah, fine.
Right. So we're not inventing a whole new, crazy.
Yeah. I get that.
Well,
I get
when
that.
you say the same way, do you mean returning trees always, or do you mean returning the same kind of thing that was given, as in,
I think the same
15
kind of
gigabyte
thing was
blob?
given. Yes, I think it was the same thing that was given.
Right.
Okay.
So
Yeah.
what it could do is it could have special code that's optimized for certain things, and the other cases will fall back to converting it to a tree expression, doing the tree thing, and then going back in reverse.
Right, and I'm sure what we should do is
that's
have. Hold
possible.
on, we should say tree of a code parse tree, just like graph of a tree turns everything into a graph, right?
Yeah, fine.
Tree of a code parse tree could just turn it raw into a tree.
Yeah, if you requested that, yeah.
Right, which wouldn't be what you would do when you're doing high performance
Correct.
classified stuff.
Yeah.
So I think the thing we need to understand is when you turn it into a tree, what you will see is these sourced element pieces and things like that in the tree. It is a tree, except that its payloads are a little bit customized. Does that make sense, Brenton?
Yeah. I mean, it makes, yeah. I mean, I'm not sure I would be the one doing it for trees, but yeah.
Well, that's just the conversion. That's just the output after the conversion.
Right.
Yeah.
Right. So one issue with this is what happens if you do a transformation that's valid for trees, but isn't really making a code parse tree? That's an error, I presume.
What kind of a thing is that?
Well, supposing you just put something that doesn't, the code parse trees have a structure to them,
obviously it's just an error. I mean, if
fine.
you try
Okay.
and glue something on.
Yeah, I think this can work. Okay.
I pretty really like this design. I think.
Yeah,
Anybody
fine.
else want to comment on this? John Fultz, if he's been.
Yeah, I've been modestly paying attention, and yeah, I think the notion of applying, the tree functions to, kind of as if, that seems reasonable. And then any new top level tree functions which are implemented in terms of other tree functions would work for free. Anything that needs to kind of dig down would need to be overloaded and implemented for for the code parser stuff. But I mean, the design seems reasonable.
Okay, so then let's, as an exercise, we need tree element, code element, and this. And it would also XML element. It will be nice to make sure that the things we're imagining working here with, Brenton's statement, you need to be able to get parents of things, et cetera, that all of that works in all of these cases. And that would be something for Ian to
Yeah,
confirm.
fine. I mean, Ian's just going to say what the language is, and then it'll be implemented.
All right. Anybody, Christopher or anybody else, you want to comment on anything here?
No, I mean, I think it sounds good.
Sounds good.
All right. Very nice. Good stuff.
Great.
Brenton, it'll be exciting to see this come
Yep,
together. This is all good.
Absolutely.
I mean, we're going to need, basically what we're saying here is that there are string names for these sort of components of the parse. Just like Chris had string names in CodeStructure, you're going to have string names in this, which you've already got, basically. Right?
Yeah, we will have to review these names and things, of course.
Yes,
but,
I know.
yeah.
I know. I'm not thrilled with the fact that they're strings, but it's probably the lesser of evils.
Sure.
For Chris's stuff or my stuff? What are you saying?
Your stuff.
Well, my stuff isn't strings though.
What is it?
My stuff is symbols.
Yeah, which we're not going to need. If we have a sourced element thing, you're just going to put everything inside sourced elements, and those tags will become strings in sourced elements.
If you say, I mean, if you want them to, okay, sure.
Well, that's what we need, because we don't want a sublanguage of some kind of extra symbols, right? Where would we put that sublanguage?
Well, the language is plus and times. I mean, I don't know. It
No, but
exists.
there's things like infix node and binary node and leaf node, things like that, Brenton, aren't there?
Yeah. So
Those
I mean,
are those are
That's
I
what we've
had
gone-
to add 10 new things to the list of 8,000 system symbols, but
Okay. If it's as small as 10, okay. If it's as small as 10 and we can have broad support for those things, then so be it. Okay, so let me understand what's an example of one of those things.
I mean, binary node and infix node, if that's what we're talking about.
Okay,
Leaf
so
node,
yes,
yeah.
okay, fine. So what is binary node?
A binary operator, at A at B, that is a binary operator.
Why don't we come up with an exhaustive list of this? And
Yeah,
then we
I
can-
So I
this
mean,
wasn't. I didn't prepare for this.
okay,
Yeah,
but hold on.
let's do
This
that.
could be a perfectly reasonable, something. I'm confused here, because this is yet another thing that reminds me of the box language and so on. It's another kind of symbolified representation. If I'm making sense, you see what I'm saying?
Yeah, you are, yeah.
Right. So what's the
Yeah,
relationship?
I mean, it's close both in purpose and and function to the box language.
Yeah, and it goes back and forth. There are functions for going back and forth. But it's not correct. I wouldn't want to use robots for
No,
everything
you
I'm
wouldn't.
doing, though.
No, you wouldn't. It would be, but this is an interesting thing. I mean, okay, we've got 3 levels of this now, because we've also got functions like infix, which was introduced in like version 1, which is a typesetting construct.
Yeah, which
Right?
may not be documented anymore. I think I can't remember.
I'm not
How does
sure.
it work?
I'm not sure, but
I'm not sure.
I think you have to put an F in there as well.
I think there's not going to be any.
Oh, yeah, right. No.
Who knows?
It
Who
may
knows?
be.
Okay,
like,
I understand, but
simple.
my point is we got to unify these concepts. And I'm not objecting, Brenton. If it's really true that you've only got 10 of these, I think
ish, yeah, plus or minus 2. Yeah.
okay, that's fine. but on the other hand, it's very different from the number of
Yes.
right. So okay, so you've got, these are abstract syntactic binary operators.
Which of course infix isn't going to work with more than 2 arguments, right?
Yeah. Okay, so I know my tendency would be to say we probably do want to introduce these, but they need to have a correct and understood correspondence to box language and to this formatting language.
Yeah. Which I would
right.
love to do in a meeting that I've prepared everything for. Yes.
Sounds good. All right. This made great progress, and this
It did, yeah.
functionality,
It's good.
and I look forward to seeing the next step.
Good
And,
stuff.
See you guys soon.